In this lesson, we are going to talk about performances, and we are going to see how to improve the performances and how to measure performances. Your target, your goal should be to have 60 frames per second. It's 60 frames per second at least, because some computer can have a better frame rate because they have the better computer, but also better monitor that can handle more frame per second. Usually those people are gamers, all right? So they have a good computer too, but anyway, they will see if the frame rate is not that good. So your target, your goal is to have 60 frames per second at least. There can be two main limitations. It can be the CPU and it can be the GPU, and we are going to talk about both. So maybe you did all great optimization about your model, texture, stuff like that. So it's not the GPU that's having a problem. It might be the CPU, all right? And you have to keep an eye on both. So we are going to test performances, but remember that I would just test on this computer, but you should test across multiple devices. You should test on smartphone, you should test on other computers, on other browsers too, many things like that. So keep an eye on everything, but also keep an eye on the weight of the website. I know that the main limitation can be the CPU and GPU for performances, but it's also a matter on how heavy is your website. If it takes hours to show your website, well, nobody will be able to test your experience. And we will talk about this too. About the setup, we are going to see many performances tips, and some have examples in the code. If you check the code, so you can see that it's a torus, a cube, a plane, and a sphere, all right? And we have some examples in it. Scroll below. It will be right here, all right? Just right here after the animate part, and we have tip 4, 6, 10, and we will just uncomment them in order to test what I'm talking about in this lesson. You can just follow me if you need, but if you want to practice at the same time, you can. So first, because we need to measure the performances, we need a way to monitor those. The first and primary thing we want to monitor is the frame per second. We need to know at what FPS we are running. And to do that, well, we used to have a great FPS meter on Chrome. I don't know what they did, but they replaced it by something you can just not use. Maybe while you're seeing this, it has been fixed and we have the FPS meter back, but let's just create a new one without using the Chrome one. We're going to use a JavaScript FPS meter. There are many, but I'd like to use this one. So it's stat.js. It's simple and efficient, really easy to integrate to our website. So we're going to do that, and it's going to add this thing to our website, and we will be able to see if the frame rates drop. So let's go to add it to your project. You will have to open your terminal on the project as always, and do npm, it's written here, install, and we're going to install it also into the project, save it into the project. So remember, you have to add save, and the name of the dependency is stats.js, like that. So you have to open a new terminal or close the server. Once it's done, well, you can remove your terminal, but remember to launch the server again if you did stop it. npm run dev. All right, looks like this. I can close the terminal. I added stat.js, so this stats.js to my project, and I can just follow this to integrate it to my website, and we see how it looks. So first you have to import it. There is not the import part in the documentation here, but it's no surprise. You have to do import stats from stats.js. This part is just the name of the dependency. You can just check that you did import it correctly. You can do like a log. All right, we get something. It's a constructor. I know it's a function, but it's a function that will construct an instance. And then we can do, I don't know, like stats. Why not? Stats or something like that, monitoring, FPS meter, whatever you want. And we will call it, so const stats equal new, and you just do stats with that constructor, that class. You save, still no error, but we cannot see the FPS meter. It's because we have to add it to the DOM. But we also have to choose between those monitoring. We won't talk about the other one. They can be great, but we won't talk about the other one. All we want is the FPS meter. So we will do stats and we will have to do, I'm just following the documentation here. It's stat dot, as always, I put the link in the links panel. Show panel, and I'm going to use the number 0, which is the FPS panel. And then you have to add it to the body, so document body. This is the way in JavaScript to get the body. So this body here, and append child to add it, append child. And it's not going to be stats, it's going to be stats DOM, all right? It's the property DOM. It's a DOM element. You do that. If you didn't understand this part, it's not that important. All you need is to have this part here. I know it's not updating right now, we need to fix that, but as long as you have the FPS, a small panel on the top left corner, it's fine. To use the FPS meter, well, you just go to your tick function, and on each frame, you will tell it to update by doing stat begin and stat, I think it's end. Let me check. Yeah, that's it. And on each second, stats will be updated. So right now it's running at 60 frames per second because I don't have much in my scene. But if I have a lot, I might see FPS drops because I'm adding like mini lights or huge texture, stuff like that. And I will be able to optimize it. See, I did some resize. Resizing is hard for the computer as always. And you can see that there are some FPS drop. If you click on it, you can access to the other panels. We are not going to talk about the other panels. All right, cool. So this is the FPS meter. There are many others. I really like this one. So please use the one you like. So we did that, begin, end. Yes, we did. All right, but the problem is maybe you're developing on a good computer. And if you're developing on a good computer, well, you will always have 60 frames per second, regardless of what you are doing, which is a problem. What can you do to test if the performances are good or not? Maybe you should test on another device. Yes, that's true. You should, but maybe you don't have like many devices, many computers, many smartphones, old one, new one, stuff like that. What I like to do is to run Chrome without the FPS limit, because right now, my screen is running at 60 frames per second. So Chrome is also running at 60 frames per second and it cannot run faster. That would make no sense. But you can unlock Chrome frame rate so that it can run as fast as it can. Be careful, your computer is going to start to hit, to make some noise, like the fans are going to run quite fast. So just do it sometimes just to test. And when you see that things are working well, just close it and reopen it. I will show you how to do that. So how can we unlock the frame rate so that it doesn't stuck at 60 frames per second? Be careful, you will have to close Chrome. So you're probably watching this video on Chrome. So first, remember what you have to do, then close Chrome, do the thing, and it will open back. So first you need a terminal. You can use your VS Code terminal, but I will use the Mac OS terminal. All right, let me increase a little so you can see. It looks like that. We go to this page. As always, I put the link on the links panel at the bottom right, and it's a gist I made, and this gist contains, the commands you have to run. I used a gist so that I can update it if this changed, because I did change for a few months ago. So I put it there. If the commands change, it will be updated here. So maybe right now you're not seeing the same commands. There is one for Mac, Linux, stuff like that, and one for Windows. So if you're on a Mac, you use this one. If you're on Windows, you use this one. So take it. You will have to put it there. Be careful, do not run it yet, because you first need to close Chrome, all right? So I will close Chrome, which will be a mess, but anyway, I have to show you. So I close Chrome, I will lose everything anyway. And then I do it. It opens somewhere else, so it's not on the right page. Let me check if I can get it back. Yep. And unfortunately, I don't know why, but the first time I do it, I never get it working. So I do it again. Maybe for you it will work, but me, I have to do it twice. Every time I have to do it twice. I don't know why. Maybe I did something wrong with that. Anyway, I will do it twice because as you can see, it's still 60 frames per second. So I close it again. I wait maybe 2-3 seconds. I start it again. I get my page back and look at that. See how fast it's running? It's running really fast. I will close it. Just remember that it's working. If it's working for you, right, close it. So get back to the video. Obviously, this video is getting cut because of that. Maybe you can open it on another browser. So I will close it, do the thing, and get back to the video. All right, I have everything back. As you can see, as we saw before, the FPS went like really high. It was close to 800, which means that everything is running smoothly. The idea is that if you are using a good computer, you know, you have great performances on this computer, but while you unlock the frame rate, you can see that it's running at 70 frames per second. Well, there is a problem. Because you're close to 60 frames per second, on a really good computer, you should be, I don't know, like 200, maybe 300 frames per second. You're going to have troubles with a computer not good as your computer. All right. This is the idea. I always do that. If I'm testing on a good computer, this computer is pretty good. It's okay. If I see that the frame rate without the limit is running at, I don't know, 80, there are problems. I will have to optimize stuff. That's all. You just disable the limit and test how well is your website running. Be careful. If you do a small window, performances are usually better, but because it's less work for the GPU. So increase the size of the window to a default, like a full screen size, and test without the frame rate limit and the FPS meter. Next part is about monitoring draw calls. But first, what are draw calls? Draw calls are action of drawing by the GPU. This is WebGL stuff. We didn't talk about that much. I think we didn't talk about that at all because we're using Three.js, that we can just use Three.js and not taking care about all those draw calls things, which is great. It's much easier. But still, right now we talk to you about this because draw calls, it's just action of drawing, and the more draw calls, well, the less performances you will have. So the idea is the less draw calls you have, the better. It's not that simple because it depends on what you're drawing, but still, if you have thousands and thousands of draw calls, it's bad for performances. But how do you monitor those draw calls? Me, I use Spectre.js. I know that there are also apps. I think you can install an app maybe on Windows or stuff like that. Maybe there are other plugins, Chrome extension, but me, I like to use Spectre.js. So let's go. We are going to install Spectre.js on Chrome. I don't think there is a Firefox version. So first, go to the website. As always, I put the link in the links panel. I will close this and this. So this is the Chrome extension Spectre.js. You add it to Chrome. You install it. Just wait a little. Spectre has been added to your Chrome. All right, great. You can close this page. You see that it's been installed. And on your page, on this one, you will trigger it. So it's inside those. I will have to click on it, or maybe I will have to relaunch it. So just, refresh. Click on Spectre.js. Maybe it will be available right here. It depends on how your extension, Chrome extension, are being visible. So we'll click on this one. Nothing. You click again on it. You can see that the icon changed. So right now it's able to record what you need. And when you want, so just, it will record everything about one frame. So maybe I can just position like, I don't know, like this, and click on it. And when I will click on that, it will record what's happening on that frame. So let's go. You might have to wait a few seconds, maybe a few minutes. It depends on how much you have in your experience. And look at that. Look at the page that just opened. You have a lot of informations. You have things about it's strange that we don't see what we needed here, but usually you have things about lights. I think those are about lights. Anyway, if you scroll a little, you will see that those are the draw calls. So you have draw calls, draw elements, draw elements, draw elements. It tells you that it's currently drawing triangles, and you can see how your scene is being drawn. Look at that. First, we get the cube. By this draw elements, triangles, stuff like that, we have a cube. And then it draws the torus knot, and then the sphere, and then the plane, and that's all. You have your final image. And if you add, I don't know, like post-processing, stuff like that, you will have more. You also have a part dedicated to lights. I don't know why it did not work this time. Maybe I will have to relaunch it. Anyway, you can see what is being drawn for the light to here. I think those are the one for the light. I don't know why it didn't work this time, but anyway, these are probably the part for the light. And yeah, well, you can just monitor things, and you will see that if you have too many draw calls, well, maybe you need to optimize a thing, and we're going to see how to optimize those. So this is Spectre.js. Learn how to use it. It can be really cool, and try to reduce the draw calls. Next thing, it's about renderer informations. It's pretty simple. What you can do it on the tick function to see on each frame, or you can just do it once when you have your scene set up properly. You have access to information about the renderer. You can just log it and look at that. You have a lot of information. Like what is being stored in the memory. We know that we have 4 geometries. Let me see. Yes, there is 4 geometries and 1 texture. That's strange. Why there is 1 texture? All right. Anyway, we have 2 programs. We have about the render 4 calls, frame, stuff like that. Frame is just how many frames since it's just like an index. And we have how many triangles. See those triangles? You can know exactly how many triangles you have in your scene. And you can see that that's quite a lot, probably because of the sphere and the torus knot. Well, you just have a lot of information. You can keep an eye on those two, maybe create graphs and show them. I don't know, you can do anything you want with that. That's all for this one. So right now we have some tools to monitor. We have the FPS meter, we can use Spectre.js, and we have informations when using renderer info. Keep an eye on those, always, all right? So next is about more general stuff. First, well, good JavaScript code. It's kind of obvious, but always do it. Like keep a performant native JavaScript code. Try to avoid things that are heavy, like a long loop across thousands and thousands of objects and array and stuff like that, especially on the tick function. All right. If you have some huge JavaScript at the beginning, well, it will result on a freeze at the beginning, like a 1 second freeze. It's kind of okay. It's bad. I know also for SEO, stuff like that, but still it's okay to have a freeze at the beginning of the website, but you cannot afford to have freezes in the tick function. All right. Because you won't have your 60 frames per second in the tick function. So the code here, you have to optimize it as best as you can. Next is about disposing things. Sorry, we did it. We're like when you want to remove something, I don't know, because the player just finished this level and then he goes to the next level. Well, you have to destroy the previous level. Don't just let them somewhere in the code. We don't care. We cannot see it. As long as we cannot see it, it's okay. No, don't do that. You have to dispose of things. And 3GS provides a page about this on how to destroy things. Just read this page and you will learn how to dispose of things. There are things you don't need to dispose, like the meshes, but geometries, materials, textures, stuff like that, you need to dispose of them. I can just provide you an example. I think it's the number 6. I can just show it to you, like to remove, let's say the cube. You can be tempted to just do that. But right now you still have the geometry and the materials being existing in the JavaScript part, in the 3GS part, and maybe in the WebGL part. And it's taking room inside the GPU memory or stuff like that. So be careful with that. Dispose of them like that. No differences, but still it's better. You can have memory leak if you don't do that. So just dispose of things. About the lights, well, the first thing I can tell you about the lights is just avoid them. If you don't have a choice, use them. The 3GS lights are really handy, like it's so easy to add lights, it's great, but it's bad for performances. So if you can do without lights, do without lights. And still, if you need lights, well, try to use cheap lights like the ambient light, the directional light, and the hemisphere light. If you use many point lights, you will have troubles, like you will have just performances issues. Also, if you need lights anyway, because you need lights, well, avoid adding or removing lights. It's bad for performances because every time you add or remove a light, material supporting lights will have to recompile. Because it's the way things are working inside the shaders, they will have to be recompiled to take into account that there is a new light or there is one less light. So try not to add light or remove light. Move them quickly, do tricks like that, but don't remove or add lights. Shadows, well, it's the same. Avoid shadows. I know it's great to just like you toggle a few parameters and you have shadows. Shadows in 3GS are really handy, but if you can do without it, do without it. And you can bake shadow. Oh, by the way, lights, a way of doing without 3GS light is by using baked light. We talk about that. And shadow, it's exactly the same. Well, because you have light, obviously you will have shadows when you bake. Well, use baked shadow. You can have like a huge performances improvement. And that's all. Because remember that before each render, 3GS will do a render for the shadows, and each light supporting shadows, we do a render. So if you have, I don't know, 10 lights, you do one render, you will have 10 more renders done by 3GS before your render on each frame, which is a lot. So avoid shadows. Next is about optimizing shadow maps. Yeah, because maybe you need it anyway. All right, let's use them. We don't have a choice. Let's use them. Well, optimize them. And we've been doing that. To optimize the shadows, first thing you should do is for each light supporting shadow, add a camera helper like that. And see if your shadow map is being optimized. Like, is the amplitude like left, top, something like that is right? Right now, it's a directional light. So this is why you can see an orthographic camera helper, and try to just reduce your light shadow map in order to fit right on the scene. And you can just, I don't know, optimize those. Maybe I already did the optimization. Yeah, it's just slightly better. You can see that I squeezed it a little and it looks something like that. See, we still have a beautiful shadow. It's probably even better because we have a smaller shadow map, just fitting the scene as it should. It looks something like that. Be careful if your sphere, stuff like that, the player can move around. Well, you will see that there is no shadow in this part. Anyway, also optimize the map size. I didn't add this one. Oh yeah, I added it there. Try to use the smallest map size possible. Use cast shadow and receive shadow wisely. So remember that you will have to tell on each object that this object can cast shadow, and this object can receive shadow, and this object can cast shadow. Let me check. We added it to every object. Right now we said that every object can cast shadow and receive shadow. Is it right? I'm not sure about that, because this torus knot can cast a shadow. Okay, I agree with that. But there is nothing creating a shadow on it. I'm not talking about the drop shadow here, the core shadow here. I'm talking about having drop shadows, like there is no object above the torus knot that could create a shadow on it. So this one should not have receive shadow true, but it has it somewhere over there. See, so this is wrong. So always make sure to really optimize this part. Only cast shadow when necessary and only receive shadow when necessary. And the cube cannot receive shadow, the torus knot cannot receive shadow, the sphere cannot receive shadow, the floor can receive shadow, yes. See, the floor can receive shadow, but it cannot cast shadow because there is nothing below the floor. We don't need to cast shadows below the floor. And as you can see, we have the same result, but right now we didn't like receive shadow on many of those, and it's just better for performances. Less to render inside the shadow map renders. So yeah, that's all for this one. Deactivate shadow auto-update. This can be really interesting. If you have, let's say, a scene that doesn't change a lot, like, I don't know, you're inside a city, there is the sun somewhere creating shadows with buildings, stuff like that, but your sun doesn't move. Like, it's just one scene with the light, the way the light is supposed to be. Well, you don't need to update shadows on each frame. All right, maybe we can say we cannot see the shadow of the player. It's okay. And this way you would just update it once at the beginning and not update it on each frame, which is really good. We just create the shadow maps on the first frame and not update it after that. To do that, it's pretty easy. You do renderer, where is it? Oh yeah, right here. You can do renderer, shadow map, auto update, false. And if you just do that, where right now it did work, but sometimes it doesn't work, make sure to do the first render. It's probably because I did it like after. Yeah, because we called tick here, it did the render, so this is why it's working. But be careful, if you do an auto update false, you will probably get no shadows at all. So make sure to do the first render, the shadow render, by doing needs update true. It will do it only once at the beginning. And as you can see, we have the shadows. It's looking great, but look at the shadow of the tourist knot. It's not moving. It's the price. You cannot have like shadow being updated. Maybe you can update the shadow every 2 frames, every 3 frames. You can have like a huge performances improvement. It's up to you, but yeah, you can just deactivate shadow auto update. So next thing is about resize textures. We are going to talk a lot about the textures. First, resize textures. Textures take a lot of space in the GPU memory, especially with MIP maps. Remember that when you use a texture, it will be sent to your GPU, and as long as we can see that texture on the screen, this GPU will be in the GPU memory. So try to use as small texture as possible on the GPU, because your GPU has memory limits. You don't want to reach those limits. The weight of the file doesn't change anything. Like it's about the resolution, how many pixels there is in the texture. And be careful, if you are using MIP mapping, which is a default behavior of textures, you will have bigger textures because you have, the version like twice smaller, saved with that texture and sent to the GPU. So always resize your texture as small as possible. And when you start to see a difference, like visually it start to see to be bad, well, just stop there. Maybe increase a little, but if it starts to be bad visually, just stop there. Also, because of this MIP mapping thing, to resize half the size, always remember to keep a power of 2 resolution. All right, on the width and on the height. If you don't do that, 3GS will resize it for you by trying to find the closest power of 2 resolution. So it will be more work for 3GS and for the CPU because it will have to create a different resolution, and it will look bad because this resolution will just kind of stretch or squeeze the pixel. It will just look bad. So always provide power of 2 resolutions textures. You can have a different width than the height. It doesn't have to be a square. Next is about use the right format. Yes, as we saw, we can use like JPEG or PNG. Use the right format. So if you need the alpha, well, maybe you can use a PNG, but maybe you can also use like 2 JPEGs. Why not? It's more on the GPU, but maybe they can be smaller. It really depends. You have to adapt to the project, to the situation. But you can use like an alpha map, very small alpha map, like black and white JPEG, and a bigger for the color JPEG. And at the end, it may be better than using a PNG. You can just try to use them the better way possible. So you can have like alpha on the PNG. And you can use tiny PNG or stuff like that to reduce the file weight. Right now, we're more talking about bandwidth, about the weight of your website. Try to optimize the images. I like to use tiny PNG. You just drag and drop images on it. Do I have any images in the project where I have this texture right here? You can just drag and drop this texture. It can be PNG or JPEG. And see, we had a huge improvement. Trust me, you won't be able to see a difference. You download it, you put it back in your project, and your file is now smaller. All right. And right now, this is a PNG. Well, I'm not sure this is a good idea. Maybe this should have been a JPEG. It depends on what you're doing with that. We're going to use that later. But I think I would have used probably a JPEG, and it would be like much, much smaller, and put that JPEG on a tiny PNG. I know the name is tiny PNG, but you can put JPEGs, it will work. Also, you can try the basis format. I really like the basis format, but unfortunately it's pretty hard to generate, which is why we are not going to use it. Basis, it's like JPEG and PNG, but the compression is powerful, like really powerful. Be careful, it's a lossy compression, meaning that the image might look pretty bad, but it will be like so much smaller. The weight of the file will be so much smaller, so much lighter. And also, it's easier for the GPU. Your GPU will be able to read it faster, so it's good for performances. have a look to basis. As always, I put a link in the links panel. Check this page, learn about it, learn how to generate those images. It's not that easy, which is the problem, but I did use it on a multiple project and it's great. So next part is about geometries. First, use buffer geometries. We talk about that at the beginning of the lesson. For every geometry, you have the default one, and you also have the buffer one. Use the buffer one, it's better for performances, that's all. I know it's harder to change like the vertices inside, but we understand how to do that. You know, it's with the attributes, set attributes, stuff like that. So use buffer geometries, always. Do not update vertices. Updating the vertices of a geometry is bad for performances. Maybe you can do it at the start, or maybe you can do it if your geometry only contains, I don't know, like 20 vertices. Well, it's okay, you can do that. But try to avoid it. If you have huge geometries with a lot of vertices, just avoid updating it, the vertices, especially in the tick function. Next, you can mutualize geometries. I have an example here. Let me check what we get if I do that. Yeah, we get something like that. All right, it's starting to look strange. Here it's working fine, but right now it's bad for performances because we are creating one geometry and one material. We're going to talk about material right after for each mesh. You can mutualize geometries, and we saw how to do that. Look at this. You just take the geometry and you put it out. So you only create one and you use it many times, and look at that. It's still working, but trust me, it's much better because you only have one geometries for 50 cubes, which is great. Next one is about merging geometries. We can go even further because right now cubes are not moving. What we can do is merge the geometries into one, because right now we can do like a spectre. Look at that. I will do a spectre test. Look how many draw calls. We have one here, one here, one here. And look at the preview. Here, we are drawing squares, so cubes, one by one. And we are doing a lot of draw calls, and it's bad. You can see that this number here, the lower, the better. And it's bad. What we are going to do is to merge them all together. So we draw the same amount of triangles, but in only one draw call. To do that, maybe you can use like Blender or stuff like that, or you can use the buffer geometry utils. It's a 3GS class that will enable like merging stuff. So let's go. First, you need to import it. To import it, it's at the beginning as always. You do import buffer geometry utils like that from, and it's inside 3 examples, JSM, utils, buffer. I will just copy and paste it because it's long to write, .js. As always, when you import something that long, just test it in the log. All right, we get it right here. You don't have to initialize it, like you don't have to create an instance of buffer geometry. You can use the method here. And as you can see, there is a merge buffer geometries. So let's go. We are going to use this one. You can just copy this part and you move back to where you were creating those geometries. All right, it's right here. And what we are going to do is create an array before. So you create a geometries array like that. This part, you move it there. So inside the loop, I know I'm putting it back inside the loop, but you will see what we are going to do. So I'm creating the geometries, and instead of moving the mesh, do stuff like that, I will comment this part because you can guess that I'm not going to use this one. Well, actually, you can just move this part outside because at the end, we will have only one material and one mesh with one geometry composed of multiple geometries. So move the material and the mesh out. You can comment it. We are going to uncomment it anyway. We create one geometry. What we need to do now is move the geometry because we cannot move the mesh as we did before because we are going to have only one mesh. So instead we create a geometry that will be all at the same place, the center, and then we move this geometry here, move this geometry here. The origin point will be the same, but the vertices will be moved at different places. To do that, we can do geometry translate, and we can use what we did here for the position. So it's math random, stuff like that. So it's X, Y, and Z. So we do X, Y, and Z. I just put them randomly. You know what? Let's just use that for now. And you create like 50 geometries and you save them inside that array. So geometries push, that. So right now we get like a lot of geometries, which is not good, inside an array, this array. What we will do now, actually you can just log it to make sure that everything is working. You see that you have 50 geometries in an array. What we'll do now is merge them all together. So we will do const merged geometry equal, and we use the buffer geometry utils, and it's the merge, I think it's buffer geometries like that. All right, it's this method, buffer, merge buffer geometries, and you provide an array containing all the geometries. And you will see that from that array of geometries, we get only one geometry, and look at that. We get only one geometry, and we can use that geometry like that. So instead of moving the things, remove all of this. We are just creating one mesh using one geometry and one material like that. Save. You get the same result. I know there is no rotation. We're going to fix that. And look at Spectre. Just do one call like that. Look at that. It's so much better. See that number? And we get all the geometries drawn as one, like that. So maybe we should have merged the cube and the sphere, maybe the plane too. We can optimize it. This amount of draw calls, it's just fine. So yeah, as you can see, you can merge geometries, and it's so much better for performances. Like really, really, really better. You can also like rotate the geometries. To do that, well, you just do a let me check. You can do it after or before. I think it's the same. Or actually, it's maybe not the same. Let's do it before. So you do a rotate X. So it's on the geometry itself. It will rotate the, how do you say, the vertices. Like that. The rotate Y, you just need to do on 2 axes. It will be fully random. And as you can see, it's working just fine. Looking great. Only one draw call. Performances are just awesome right now. All right, that's cool. Let's talk about materials. First, you can mutualize materials. And I think I will do the exact same thing. So I will get back to the example I just had before. So you can do it with me. Let me check. Oh no, actually you can let this one. I did 2 examples. So let what we did with the geometries. You can comment it, I think, and yeah, uncomment the 19 like that. So we have the exact same example, all right? But without the merging thing we just did. You can keep the code, it's up to you. We do something like that, like that, like that. All right, so 19. The idea is that you can also optimize the material. So just like we moved the geometries outside, well, you should move the material outside, because all those meshes are using only or using the same material. And you should look at your scene. Just check which materials are the same and only create one and use it on every meshes that can use this material. And that's all. By just doing that, you just improve performances. Also, try to use cheap materials. You have many different materials, but if you can use, like if you're using physical material, standard material, it's huge materials that are bad for performances. They look great, so please use them if you want something realistic. But if you can avoid using them, like if you don't need something that looks that great, but still you want some shadows, maybe you can go for meshed Lambert material or mesh Phong material. And if you don't need, like you just need like a color on it, well, use a basic material, right? Try to use cheap materials. Next one is about meshes. So let me check this one, 21. So we had an example on the 20. Yeah, I kind of mixed everything. So this was the mutualized material. Yeah, I kind of mess with everything. Anyway, the examples on the starter are great, so just follow the examples. I will comment this one. So this was mutualized material. Cheap material, great. Now the meshes. Let's go even further. So it's 22. Look at that. Here we saw that the solution was to merge the geometries together. But sometimes when you merge everything together, you cannot move each cube. Like if I merge everything, which is not the case here, but imagine that I did merge everything, I cannot move this cube without updating all the vertices of the geometry, which is bad. We saw that. So we don't have control over each cube, which is sad. But there is a solution. This solution is called instance mesh. The idea is that you're going to create only one instance mesh and provide a transformation matrix for each instance of that mesh. So right now we are going to create one instance mesh, but create one matrix for each cube. You will see right after. The matrix has to be a matrix 4, and you can apply any transformation on a matrix 4, like say you can do like this matrix will do a position change, like a translate and a rotation, and this matrix will do also a position and a rotation, and this one will do a scale or stuff like that. This is what matrices are made for. So let's go. What you will do, so this is already optimized, like the buffer geometry is outside, the material is outside, but right now we are creating one mesh for each cube, which is already pretty good, but we need to use instance mesh to have even better performances. So let's have a look to the Spectre. Let's run Spectre once. So we get something like that. All right. So let's go. We are going to create, as I said, only one mesh, but it's going to be an instance mesh. We are going to do mesh equal new 3, and it's going to be instanced mesh. So it's already available inside the 3 variable. Great. You provide the geometry, you provide the material, but you also have to say how many elements, how many instances you're going to add. And I will add 50 instances because right now we are creating 50 meshes. Then this is where things get complicated. You need to create a matrix, and creating a matrix, and I think you can add it already. Yes, don't forget to add it to the scene. I forgot this part. So add this instance mesh to the scene. So right here, I will comment this part, and we need to create a matrix that will do the position change and the rotation change. And we're going to use 3 GS matrices, which is over there, right here. So first we create that matrix. So we create 50 matrix actually, because we're inside a loop. So let's go, we do const matrix equal new 3 matrix, and it's going to be a matrix 4. And we have to provide this matrix to the mesh. And to do that, we do mesh set matrix at, and you provide the number, so 0, 1, 2, 3, 4, 5. So it's going to be at I, because I already have this I, and you provide the matrix. And actually, I think you can just test like that. And you see that it's working. Every object, we have 50 objects right here using this instance mesh. The problem is that that matrix is not doing anything. The matrix is not telling to move somewhere or to rotate somewhere. So we need to transform that matrix. Don't worry. We can just use like a method right here. And we have things like, let me check, make rotation. Well, you're going to use this one. Make rotation from quaternion. You provide a quaternion and it will transform the matrix to do a rotation. And then we can do like set position to also say that this matrix, so this is matrix doing a quaternion, like a rotation, but then we will also change the position, and you can just provide those. You can also do like a scale or stuff like that. So let's go. We're going to start with the quaternion. We can start with the position. No, you know what? Let's start with the quaternion. So we're going to do const quaternion equal new 3 quaternion like that. And we're going to use quaternion and set from Euler, because I think Euler is so much easier for people bad at math like me. I will provide a Euler. Actually, you can just use like a set. I think you can do like matrix, make from Euler or stuff like that, but I want you to use also the quaternion. So we will use a Euler to create a quaternion and use that quaternion on the matrix. There are shorter versions, I know, but I want you to use Euler and quaternion and stuff like that. So we create a Euler. It's going to be math random, you provide the three values of the Euler, 0 at the last one. So I can put it like that. Math random, so it's going to be the exact same thing, like that. So it's gonna be, let me check. Maybe I did a mistake here. No, it's like that, it's like that. All right, be careful, we have many parentheses. So the first value is going to be that one, the second value is going to be exactly the same, and we don't need to provide the third value because it's doing a full rotation anyway. So you can do that, and then you can say your matrix to use that Euler. So you're going to do matrix, make rotation from quaternion, so not Euler, quaternion, from quaternion, and you provide this quaternion. I know it's long, I know you will have to dig a little to understand this, but as you can see, it's looking great. It looks like the rotation did work. All right, now we need to play with the position. It's going to be easier. We started with the hard one. I wanted to get rid of the quaternion and then do the position. You can do const position is going to be a vector 3. Vector 3. I said 3, yeah. And we are going to use the same random values. It goes from -5 to +5, like that. So we create a random vector, putting things anywhere like from -5 to +5 on all three axes. And then we can update our matrix, which is already doing like a rotation from a quaternion. We can do, I think it's set position, yeah. Set position, and you provide a vector 3. We already created here. You save, and look at that. It's working. But right now, we are using a much better way. We still have control over those. We can update each one by updating the matrix. We are not going to do it, but trust me, you can just update the matrices on the mesh. You can provide a new one, or you can change it inside the instance mesh. Sorry, so inside this variable. And let's have a look to the performances. I forgot how many we had before. Can we check it? Anyway, look at that. There is only one draw call doing all of those, and we can still control them by changing the matrices. All right, we are not going to do it, but trust me, you can still control each cube by doing the matrices. Why are we not doing this all the time? It's much better, but it's hard because we need to handle those matrices. So if you can do it, it will be longer, harder, but still it's really good for performances. So please do this. All right. One more thing is, if you know that you're going to update those matrices like on each frame because you want your cube, I don't know, to be animated, stuff like that, you have to provide this. This is not mandatory, but it's better for memory management, stuff like that. So you do mesh instance matrix set usage 3 dynamic draw usage. All right. If you know you're going to update those on each frame, set that to 3 dynamic draw usage. It's just better. I read that from the documentation. I could not see a difference, but if the documentation says you have to do it, well, let's do it. All right, next part, let's talk about models. First, try to use low poly models, because the fewer polygons, the better. Just try to use low poly models, that's all. And if you need details, like, I don't know, like scars on the face, stuff like that, well, you can use normal maps. Remember the normal maps? Use them to add details. Next, about Draco compression. Well, if you have a lot of details, a lot of vertices, you don't have a choice. You need those, like it's a huge city or human body with a lot of vertices, stuff like that. Use the Draco compression. Yes, it will result in a freeze at the beginning because you need to uncompress the geometry, and also because you need to load the Draco library, so it can be like slightly longer to load, but the files are going to be so light, so much lighter that you should do it. If you don't have much, like if you have, I don't know, 3 low poly models, don't use Draco compression. Next is about gzip. What is gzip? Gzip, sorry if I say it wrong. Gzip is a compression happening on the server side. So we won't do it because I don't have like a server running. I mean, I have one, but I won't show you how you can do it because it really depends on your server. If you're using Apache or Nginx or stuff like that, just try to find how you can do that. But the idea is that gzip is compression happening on the server side. It's doing it for HTML files, for stuff like that, for video, etc. But it's usually the server don't handle gzip on GLB, GLTF, OBJ, and stuff like that. It's the case of most of the server I had until those type of files are not being gzip, but it's so much lighter when you gzip them that you should activate this on your server. And I can show you the difference on my portfolio. Look at that. My portfolio, when you start, look the weight, it's right here. Let me show you. This is how much has been loaded, 3 megabytes. This is the final weight, 8 megabytes. This is the gzip happening. If I remove the gzip from the server, I will have to load this. See the difference? It's so much lighter. So activate the gzip. It's very important. And you can see if a file is being gzip, you can click, I don't know, let's find some models. Where are my models? Maybe over in images. So it's like that. All right. Headers. So you click on one of those assets. I know the name doesn't make sense. It's because I'm using some hash, and you can see that content encoding gzip, right? I just click on one of the assets. I can see that it's being gzip. So it's the server compression, and now it's working, and my website is so much lighter. Let's close this one. Next is about cameras. Well, it's a kind of thing, it's a little sad, but when objects are not in the field of view, they won't be rendered, all right? If you're looking in that direction and you have objects, well, behind, those objects won't be rendered. What some people, it's a totally solution, but what some people can do is just reduce the field of view to have less objects to render. This can sound like a bad idea, but trust me, there are many games doing it. Like they know they have bad performances where they just reduce the field of view, and most players don't change that field of view. It's bad because you can see enemies on the left and right, but it's less objects to render. So if you have frame rate problems, maybe you can just slightly lower the field of view. And just like that, you can also reduce the near and the far. Remember that if something is further than the far, it won't be rendered, and if something is closer than the near, it won't be rendered. If you have like a huge city with mountain and stuff like that, maybe you don't need, like if you're inside the city with tall buildings, you cannot see like the village far away, like the mountains behind, because there are buildings all around. So maybe you reduce the far, and those won't be rendered. It's a way of doing it. Next is about the renderer. The pixel ratio, we did that already, but I want just to remind you about that. When we set the renderer pixel ratio, don't use the default pixel ratio. See this one? Window device pixel ratio. Don't do that, because some devices have huge pixel ratio. It's just marketing. We do above 2, it's useless. Maybe 3. I don't know if you have like a you're always looking at your cell phone or your screen at 2 centimeters from it. Okay, why not? But still 2 is more than enough. What I always recommend is to limit it to 2 by using math min. It will provide you the minimum value between the device pixel ratio and 2. If your device pixel ratio is 5, you will get 2. If your device pixel ratio is 1, you will get 1. All right? Limit the pixel ratio. Power preferences. Some devices may be able to switch between different GPU or different GPU usage. I saw that a friend of mine had like an external GPU. You can just plug the GPU. It's much better than its computer GPU. You plug it and you can do like, I don't know, like use Cinema 4D or stuff like that by using that GPU. You can provide this. So let me check, where is it? It's over there. When you instantiate 3 WebGL renderer, the renderer like that. So when you create the renderer, you can say, use the best, use the best GPU possible. And just by doing that, maybe sometimes it really depends. It's hard to say that it will always work or not. You can just provide it and hope for the best. It will use that like the best GPU to handle your WebGL. That's all. Just provide power preferences, high preferences. If you don't have frame rate issues, don't do it. Right? Let's not use that GPU. Maybe it's for something else, for another purpose. So if you don't have frame rate issues on computers, don't set that to high performances. Just don't set it. Just remove this part. All right. Next part is about anti-alias. The default anti-alias is performant, indeed, but it's less performant than no anti-alias. So if you can just get rid of the anti-alias because it looks the same, well, get rid of it. Just like if you have, if the pixel ratio of the user is 2, you don't need an anti-alias. It will be bad for performances, and the user don't need it because it already have enough pixels on the screen. Next part is about post-processing. First, limit passes. We saw that passes are great, like you can add cool effect on your screen, but passes are bad for performances. Try to use as less passes as possible. Try to merge them together. Like if you're creating your own pass, maybe not create like 3 a time your own pass, try to merge them all together if you can. It will be better for performances. Why? Because every time you do a pass, you're rendering those pixels. Like if you have, let's say, a default resolution of 1900 multiplied by 1080. So this default resolution, you will have already a lot of pixels to render. All right. If you do one, let's say 4 passes with a pixel ratio of 2. If the pixel ratio of 2, well, you multiply this and you multiply this because it's on the width and on the height. You have 4 passes where you multiply by this. This is how many pixels will have to be rendered on each frame. It's way too much. You will have performances issues because you just added 4 passes on a retina display, like on a display that has a pixel ratio of 2. So try to avoid passes and merge them together, and that's all. About the shaders, well, you can specify the precision. We talk about this. When you use like a shader material, let me check if I have one. Yeah, this is this one. So I have an example. We will activate this one. Let me check what I have to do exactly to activate it. I think it will look exactly. I have like just a small experiment just to test stuff. I will command the rest. All right, let's command this. I will also command the objects. I think there are this one here. Yeah, I can command this. I commented all the examples. I can keep the light. Anyway, that's not a problem. Let me check if I remove it, what happened. All right. And I can remove also the floor and stuff like that. So the test meshes like that. Alright, I just commented everything. I get an error obviously because I'm trying to animate them. So remove the scene add of each of those, like the sphere and the floor, like that. Refresh. Alright, you get something like that. It's just like a shader I did. I won't go into detail about that. And we're going to talk about optimizing the shader. First, if you are using a shader material, you can precise the precision by doing precision and set another value like low P. Remember, we have low P, medium P, and high P. If you don't provide anything, 3GS will most likely use medium P, but we also adapt by testing if the device can handle low P, medium P, or high P. So you can just let the default, or you can use a different one. Is it different? No. It looks the same, but right now we are using a low P precision, which is better for performances. So it's up to you. I know that this might result in errors. Test, see if there is like a huge change, but right now it's looking exactly the same, so you can use that. Next one is about keep code simple. This is hard to monitor because it's inside the shaders. I'm talking about the shaders right now, but keep the code simple as possible. Avoid if statements, all right? If are bad for performances. Make good use of swizzle. You remember the swizzle? It's like doing now we have the model position. We do model position, X, Z, Y equals something, stuff like that. This is the swizzle. If when you use just part of one vector of 3 or vector 4 to do things. I have some example to provide you. Let's say we have this one, like here we have a if statement. If, so we get the elevation from a texture. This is the texture, all right? We send this texture, which is not really optimized, but anyway, this is the texture we send. And I'm using this texture to create this kind of demonic landscape, stuff like that. So it's looking great, but anyway, I'm saying that if the elevation is below 0.5, well, I clamp it to 0.5. If I remove this part, you can look that the floor is getting like really deep inside here. So I did that. I can't improve that by doing elevation plus, so elevation equal, and I do a clamp. Remember the clamp, you will limit it. I can also use like max. Anyway, I can do elevation 0.5, 1.0, and then something like that. All right. I remove the if and I got something like that. I get the same result, but no if, because I use clamp. I can also do with like max. So it's going to be the max between those. Oh, sorry. So it's between this and this, like that. And I get the exact same result, but no if. It's better. And I can go even further. Instead of creating a variable or changing a variable like that, well, I can just take it and put it, I don't know, we can put it like over there, like that, and multiply it by that. Yes, and we get something like that. We get the same result, but I got a much simpler code right here. I can do the exact same thing here. So it's going to be, let me check, it's going to be the max between this one and this one. Well, I can just remove it, like do elevation equal, what value was that? 0.25. So it's max between elevation and 0.25. I remove the if by using those kind of functions. All right, cool. And you can use it the same way. Let's move forward. Or as in a fragment shader, instead of this complex formula for RGB, yes, right now we are taking a depth color. So this is the red color at the bottom. We have a surface color, so this is the color on the top. We have the final color, I just create a random value, and then I kind of interpolate it. So I start from the depth on the R channel. I add the difference between those two, so the depth and the surface, and I multiply it by the elevation. All right. In fact, right here, I'm doing a mix. I'm just doing a mix. And I'm doing a mix for R, G, and B. And we know how to do a mix for R, G, B. This is just like an interpolation between two values. This is the hard way of doing it. You can also do, look at that. You can remove all of this and say final color equal mix. It's a mix between this one and this one, depending on this one. Like that. Instead of doing all of this, I'm using this. Will I have a problem? Let me check. No, it's a vector 3. Yeah, it should work just fine. I've saved, or I did a mistake. Let me check where exactly. Always check the error. Final color and declare identifier. Oh yeah, because this variable doesn't exist yet, you have to create it. And when you create a variable, you have to provide the type like this. And see the result? It's the exact same result with only one line of code using a mix instead of those 4 lines of code. And it's much better. Next part is about textures. I won't be able to show you, but to create this, I could have used like a pairing noise. Yeah, and pairing noise is just great. I love to use pairing noise, but pairing noise is bad for performances. It's a lot of calculations for the GPU. Sometimes you should just use a texture. Go into GIMP or Photoshop, create a texture, tweak the texture until you get something that looks the same as the pairing noise you wanted to create, and picking the pixels on a texture can be much better in terms of performances. You won't be able to animate it. You won't be able to tweak it without opening it inside GIMP or Photoshop, but still, it will be much better for performances. So try to use texture instead of complex formulas, a complex algorithm. Next one is about the defines. We didn't use much the defines, but if, so uniforms are great because uniform, you can animate the value and you can also like tweak it with that UI and change it in the JavaScript. So it's great, but it's bad for performances. It's not that bad for performances, but if you want to optimize everything, let's optimize everything. So instead of having a uniform like that, well, we could just have put the value somewhere like this. I could have do something like that. All right, and I can remove the uniform. But still, I don't like having just random values inside my code. What I can do is use defines. And to create a defines, well, there is 2 ways of doing it. You can create it inside of it. Look at that, I will remove this. So I take the name, it's uDisplacement strength. And here, I'm going to do hash define uDisplacement strength, and I put the value. Like no equal or stuff like that. I just put the value after the name, like that. I can remove this part. Look at that. Let me check if I'm using it here. No, so okay. So I remove the uniform, I save, and it's still working. And I can still change the value right here. This way I can have like many values here. Obviously you can also change the name. We usually use something like a displacement underscore strength. So it's up to you, you can do whatever you want. You can like distinguish them easily if they are in uppercase. and you get exactly the same result. I know we cannot animate them, I know we cannot tweak them, but still it's better for performances. The other way of doing it, you can remove this part here and add a defines property here with an object, so inside the shader material, and set the name like that and the value like that. And we get the same result. Those parts will be added automatically because it's a shader material, not a raw shader material. So this, it's like, just like we did before. So it's exactly the same as doing that, but you provide them here. Be careful if you change those defines from like later, like in the tick function or stuff like that, the material will be compiled again. So it's bad for performances. Don't change the define. You just provide them. Don't change them. This can be like easier to tweak the values or just to test other value. You put another value. You look, it's looking great. Let's keep that one. All right, cool. Next one is about doing the calculations in the vertex shader. Like right now, we are doing a lot of calculations inside the fragment shader. I mean, not a lot. It's okay. But what you should try to do is do the calculations here and send the values using varyings. Remember the varyings? It's better to do it on the vertices or the vertex shader because we have less vertex shader, usually less vertex shader than fragment. All right, we have less vertices, than fragments. So try to do the calculation in the vertex and send the result to the fragment by using varying. So we're going to do that together. It might be a little hard, but let's try it anyway. So right here, what can we really move to the vertex shader? Actually, I think we can move like everything. We can move like the final color. Like we can calculate the final color. Maybe we will lose some details. It depends on how many vertices. Here you can see that we have some very small details. It's looking great, but still it's bad for performances to do a lot of calculations inside the fragment shader. So we are going to calculate the color inside the vertex shader. So let's go. I might do some mistakes, but anyway, let's try it. So I have this part. I won't touch this part, and we just do the same here. So I have the elevation here. Yeah, it's not the exact same limit, but still I can use it. Let me check. Yeah, we have this one, this elevation. All right, what I will do, follow me on this. So this is about like the position. Maybe I can just like position in order to see more clearly. Color, and here we just do maybe I can move that here actually. Yeah, you know what? Let's move that here. So we have everything about the position. And then we're going to do things about the color right here. And then there is the varying. We are going to get rid of this one. So the color, well, we can do the exact same thing. So we do a float color elevation because I cannot call it elevation because I already have an elevation variable here. I'm doing a new one because it's not the same value. So let me check. Oh yeah, we are already taking the R value and right now it's the R2. So what I can do is just do color elevation equal and it's the elevation like that. So I take the elevation I already took from the texture to move the vertices, and I just set a max value to 0.25, like that. Okay, cool. So I have already did this part. Then I can calculate the color. So I will just move. See, I'm removing everything from the fragment. So I take the color elevation, and I use it to mix between this color and this color to do something like that. Actually, I can also like move those here and move this one here. I like to have separated variables, but anyway, let's optimize everything. And it looks something like that. So I'm doing a mix depending on the color variation. Yeah, looking great. So this one is not working anymore. So right now what we're going to do is send this one. So I'm going to do varying. It's a vec3 because it's a color. It's going to be just V color because it's the final color, the V color anyway. I'm going to call this one, well, color, not final color. We don't care. There is just one color right now. And I will update it by doing V color equal color. I could have put the color right inside the V color, but I like to have the varying at the end separated. Let's keep that anyway. And we are going to fetch this from the fragment and put this right here. So I retrieve the V color I set in the vertex shader and put it here. We can save. We're going to have maybe a warning. Yes. So as you can see, it looks the same. We have a warning telling us that we are sending the VUV. We are not using the VUV anymore. So remove the VUV like that. remove the VOV like that, and this one. So we only have one varying, we save, and we get the same result, but we are doing nothing inside of this. And we can also remove the texture. Look at that. I remove the texture. This is my fragment code. There is nothing inside, and I'm doing all the heavy lifting from the vertex shader, and it's better for performances. See? And I can even optimize more all of this, and it's looking great. But we did lose some details. Like, look at this. We don't have the same details because we have less vertices. It doesn't look the same, but still it's so much better in terms of performances. And that's all. I know it was quite fast, but if you get the idea, do the calculations inside the vertex shader if you can. So yeah, you can go even further. Keep an eye on the performances from the start. This is very important. Do not wait for the end of the project to test on other devices and discover that this is bad. You have really bad performances. Fix the performances as you go. All right. From the start, you have to keep an eye on performances and test on many devices, and also test on smartphone. All right. You're going to have troubles if you don't do that from the start. And also fix any strange behaviors. Like if you don't know why there is so many vertices, or why there is so many draw calls, there is no shadows, no geometries, and still we have like, I don't know, 20 draw calls. Fix that. Remove things and see which part is doing those draw calls. And from the start, very important. Each project will have different constraints. Applying those tips won't always suffice. Maybe you will apply every tips I just shown you, and still you will have problems. You will have to adapt. All right. Try to find solution. Twist the way you are doing things. Maybe use texture. Maybe merge things and then unmerge them and do something like that. Maybe calculate the normals at a runtime or something like that. Be smart. Find solutions. You will find better way of doing things throughout the project. It's all about having experiences, like do project and practice, and you will start to learn many things, and you will start to adapt more quickly. At a point, you will know multiple ways of getting the same result. Like, I don't know, you know that you want to get that result, and you will know multiple ways of getting to that result. And you will find the best one, which is performant, not that hard, easy to change, easy to tweak, easy to animate. You will just be able to choose the best solution. And through the projects, you need some practice. And by the way, here is another big list of tips to improve how to use Three.js by Lewy Blue. So thank you, Lewy Blue. I hope I say it right. So Lewy Blue, and it's on its Discover Three.js website. You have a lot of things, probably many we just saw, but look at those. You can learn a lot. And that's all for the lesson. I'll see you in the next lesson.